All right, today we're going to talk about minerals. Minerals are the natural, solid, inorganic, with definite chemical composition and crystal structure. They have to be all five. You can't have one and not the other. So now let's go through it and make sure we know what that means. Natural, meaning it cannot be formed by a person. It has to be made by Mother Nature. Solid, this phase of matter, so it can't be a liquid. It has to be solid. Inorganic, we heard organic when we talked about sedimentary rocks. Organic means living. So inorganic means never living or never made of something that was living. And then chemical composition, referring to its actual atoms that make up the different elements inside of it. And then crystal structure. Remember, crystal is a repeating pattern or arrangement of atoms. Now, we use minerals in our everyday lives pretty frequently. I would say most commonly I use calcite to brush my teeth in the morning. It's part of toothpaste. I use salt on my food. But there's a couple of things that you may not expect that have to do with minerals. And one of them would be our metals. Metals we usually get from ores, which were part of a mineral at one point in time. So keep that in mind, that minerals are an important part of things that we use in our everyday lives. There are lots of different types of minerals. The most common is going to be silicates. So we're going to get back to silicates in a second, but first we need to know, where do these minerals come from? Well, they come from magma, which is when it comes out of a volcano or forms below the surface as magma is hardening and cooling down. So it's sort of like our igneous rocks. Our igneous rocks create minerals inside of them because minerals make up rocks. And then minerals can also form from solution, like our chemical sedimentary rocks. So if they precipitate out of a solution, or if the water evaporates, it could leave them behind. And those minerals would be part of a chemical sedimentary rock. So those are the minerals that we see on an everyday basis. So let's look at some of the ones that are pretty common in our area. Quartz is that white crystal, or sometimes clear. Feldspar can be pink or white. Muscovite is generally what makes minerals shiny. It's really common. We talked about it. We call it mica for short. And mica is really common in metamorphic rocks. We're going to use that as our indicator that a rock has gone through metamorphosis, because it's going to have those sparkles on it as it goes deeper or gets hotter inside the ground. Now, mineral groups include native elements, which would be copper, diamond, anything that only contains one type of element. Then you have the oxides, which are used for ores, our halides, which are the salt group. So these halides here, that's what would be salts later on. Carbonates, which are the ones that fizz with acid. And then sulfates and sulfides are the ones that contain sulfur, that stinky mineral we talked about. And then we have our silicates, like olivine or quartz are some of the really common ones. So let's talk about silicates. So silicates are 96% of all the minerals on the earth, which means if you pick up a rock, more than likely it's going to be these silicates. Quartz is the one that I think can be the prettiest at most often, and quartz has a variety of shapes and colors, but it's pretty common in this area. Then you have the carbonates, which can also make these nice vibrant colors like azurite and malachite, and their biggest indicator would be they fizz with the acid test and release carbon dioxide. Our oxides are used for ores. These would be the ones we'd go into the ground and then melt down to extract what we want. Now, when we go and look at a mineral, we don't automatically know what it is. We have to go through some tests to identify it. One would be hardness. Hardness uses the Mohs scale, from 1 being the small or the least hardness, or the least hard, it's the softest, and 10 being the hardest. So diamond is the hardest mineral on the earth. Now, quartz is pretty hard. It's a 7, and that's one that we have pretty frequently used to make glass and things of that nature. So hardness is how resistant it is to being scratched. The bigger the number, the harder it is. Crystal shape can be helpful. Sometimes the atoms arrange themselves in a way that can be seen outside. So meaning when it forms outside of the earth, we still see the shape. But oftentimes the shape has been distorted because we broke the rock off of another piece. Luster can often be helpful. It's how light reflects off the surface. And it's either going to be non-metallic or metallic. Metallic, like this one right here, looks like a metal. That would be pyrite. Pyrite looks sort of like gold, so they call it fool's gold. And it's very, very much so metallic. Now, the non-metallic ones can just be shiny. One example of a non-metallic would be quartz. It's just a glassy looking rock. Now, color can be helpful. and also not helpful. If you have a white rock, probably not so helpful. But if you had that bright orange sulfur that we looked at in lab, that would be something that would make it very easy to identify. Streak is the color of the mineral's powder, so it's inside. Some minerals, like the one seen here, this is hematite, have an outer color that's different than the inside color. So it appears gray on the outside, and then it's red on the inside, which makes it very much, different and harder to see the outside unless you take it and rub it across that streak plate to get its streak like you would when you were looking at it in lab. Now, mineral cleavage and fracture can be helpful. Some minerals split along flat surfaces. That's cleavage. So if a mineral breaks into sheets like mica, that would be an excellent way to identify it. If it makes a certain shape or has flat planes, that can also be helpful in identifying. And fracture means it breaks unevenly or even curved across its surface. Density can be helpful if you have a very heavy mineral. In lab, we looked at this one, which is called galena. Galena is metallic. You can see the light reflecting off it, but it's also very heavy. You pick it up and you don't expect it to be that heavy. It has a very high density. Special tests include the acid test. We dropped acid on calcite in lab because if you drop acid on calcite, it's a carbonate. It's going to react with the hydrochloric acid and produce CO2 gas bubbles or carbon dioxide. Fluorescence we looked at with the black light. And what fluorescence does is it produces a glow when it faces UV light, like a black light would produce. So it makes a nice glow of color. Salty taste, hopefully we didn't experience that in lab, but salty taste is another special characteristic. Halite, one of our salts, is an actual salty taste because it's a member of the halide group and because halite is in fact table salt. Magnetism is our last special test. Magnetism is pretty important. Some rocks actually attract magnetic pole. And what that does, it attracts a magnet, would be how we tested for it in lab. And those examples are lodestone and magnetite. Lodestone is what we used to make the first compasses when we were exploring different parts of the world, back when the exploration days were just starting. So those are our minerals. Now just keep in mind, important things about minerals are going to be how they form, either from magma or solution. And you also want to keep in mind the big mineral groups like the silicates, the most abundant, oxides, ores, and then your carbonates fizz with the acid test. And then you want to also remember the characteristics that make a mineral. They have to be natural, solid, inorganic, with a chemical composition and crystal structure. And then how we identify them, the special characteristics we just went over, as well as your luster, your hardness, and your streak. So keep that in mind when you're studying for the test.